Sorry, the next talk is by John Daniels, Data Engineering Director at BENlabs, and Eric Riddoch, the ML Platform Lead at BENlabs, who will be describing how to build the ML platform at BENlabs. So thank you.
Woo! Thank you. And thank you, Netflix. Thank you, Villa. Isn't he amazing? Hard steps to follow him. Well, I'm John Daniels, and Eric Riddoch and I are going to walk through how we've built a data platform and an ML platform at BENlabs. We're going to kind of open up and reveal let you into our kitchen, so to speak, and reveal how we've built these things. First off, I want to start by telling everyone, my wife and I had 7 kids in 9 years, and we're looking to adopt more. When I'm in charge at home, our house is complete chaos. When my wife is in charge at home, things run very smoothly. And it's because she put systems in place that enable that to happen. For example, she got sick and tired of having to run around the house and call the kids for dinner when it was dinner time. That task alone took a while, and she didn't like yelling across the house. So what we did is we set up Alexa devices all over the house, and now all we have to do is say, Alexa, assemble. And an audio soundtrack goes on of the Avengers theme song, and the kids know that they have 30 seconds to make it from wherever they are to dinner. Because if they don't get dinner. Just kidding, we feed all of our kids. Unless they're being naughty. But that's what I want to talk about today. Putting the platforms in place to make these data products real is a very important step. We're going to talk about some of the principles that did that. But first, let me tell you about who we are at BENlabs. So BENlabs is a product placement company. What does that mean? What that means is we're the reason why Tom Cruise wears Ray-Ban sunglasses in Top Gun. We're the reason why James Bond used to drive BMW in the Bond series. We're the reason why Barbie drives GM vehicles in the Barbie movie, and a slew of other product placements, including Netflix's very own Stranger Things, where this scene happened where a family was eating a bucket of KFC. We also work with content creators to integrate ads into and products into their campaigns. We work with folks like Mr. Beast and big folks like Dude Perfect. You probably have seen them, as well as small creators. And we have a software product called TubeBuddy that helps big and small creators capitalize on the creator economy. What you see over there on the far right is an image of one of our thumbnail analyzers. This is a feature inside of our TubeBuddy software, and you're seeing the attention on the thumbnail, helping it determine which of the thumbnails is going to be most likely to get clicked on for click-through rates. All right, let's jump in to how we're building a data platform and some of the principles that got us here. I'm primarily going to be speaking from first person so that you can see how my experience, and like many of you, your experiences have shaped the reality that you live in. First off, my professional experience started as a missionary for the Church of Jesus Christ of Latter-day Saints. I spent 2 years living in Japan, learning about my half-Japanese heritage and teaching people about the gospel of Jesus Christ. Because of that experience, I became the 12th employee at DigiCert, where they were interested in my Japanese language skills. Had the great opportunity to learn about Python and really good leadership there. Went to a number of different graduate skill universities, and then here I landed as one of 50 data scientists at M&T Bank. Fantastic employer, fantastic employment experience. As one of 50 data scientists, we were building models that were predicting the likelihood of someone not paying us back on multiple types of loans. This environment was so fun to work in, but when it came time to deploy those models, guess what the interface was? Yes, Excel. And it was a nightmare. Having to redeploy and rerun your models just to get it into that interface so you could have your one line in there was absolutely horrible. This is where the first principle of making sure that you have a platform team in place is really, really critical. And that the engineers or the data scientists using that platform have easy to use self-service tools becomes absolutely important. From there, I got recruited to start the first data science team at Georgia Pacific. In case you don't know, Georgia Pacific is one of the largest paper and pulp manufacturers. They make great paper products that you may have heard of: Angel Soft toilet paper, Dixie paper cups and paper plates, Browning paper towels, and Quilted Northern. My oldest son at the time thought that I worked at an Angel Soft toilet paper making factory, and he thought that was cool. So I never corrected him. At Georgia Pacific, the lesson and the principle of using tried and true technology was very, very important. We were the largest manufacturing customer for AWS at the time, and we were moving all of our on-premise data centers into the cloud. At that time, the AWS folks were showcasing SageMaker. And SageMaker, while it looked like a cool and flashy tool, didn't support anything that was built on Python 3.7 and above. We had already written a number of algorithms and had forecasting algorithms in place, so we weren't about to rewrite that code. Using that tried and true technology became a critical component. From there, I went and worked at a consulting company called iBailey, where we helped deploy lots of data and ML platforms, proof of concepts, and also that's where it became it became important, and I realized the need for having that launch pad, an actual platform where you can build great products. Had the opportunity to work at Bamboo HR, fantastic software company, and the principle of managed open source was absolutely important here as well. We found ourselves in a situation where one of the data vendors that we worked with hiked up the price on us, and there was nothing we could do about it when the contract came time to renew. We also had the opportunity, you can't see it on the slide, it looks like it got cut off later in our career, to meet with some of the folks at the Uber data engineering team. And you could see that they had taken advantage of open source software as well. And they were able to fork it to meet their needs. From there, I got the opportunity to work at Actify. And then from Master Control, and now here at BENlabs. Now the last two principles that I'm going to talk about are absolutely key that everyone should be thinking of all the time when you're thinking about platform tools. First one is human-centric design, and the second one is leadership. And I don't just mean people leadership, but also leading out, thought leadership, being brave enough to start and push forward and fail and try again. This is very important. In summary, this is the reason why we do what we do at BENlabs and on the ML platform and data platform teams. We try to make the world a better place for these people. And as you can see, the ratio of one to many is very important. Otherwise, we wouldn't be able to get the jobs done that we're trying to accomplish with easy-to-use self-service tools. To summarize, many to one, or one to many, self-service tools, managed open source, tried and true technology, human-centric design, and leadership. Now I'm going to peel back the onion a little bit and let you see what a good data platform looks like and some of the principles to building that. These things should be easy. You should be able to pull any data from any source at any scale and at any speed. What does that actually look like? Here's the data engineering lifecycle. You start by extracting and loading data from any data source, dump it into your data lake, and you're doing transformations inside of a data warehouse. Then you're serving that data to your end clients. Here, I'm going to talk about 3 different types of architectures, and what I'm trying to illustrate here is how simple they are. Seeing how simple they were was kind of life-changing for me. So, Lambda architecture. Basically, you have a speed lane and a batch lane. What does that look like for us at BENlabs? A creator could be live streaming something, and they want to see sentiment analysis for how people are reacting to their live stream in real time. So anything that needs to go that quickly is going to happen in a speed lane. Batch lane is basically anything that's happening and refreshing the data once an hour, once a day, once a week, something along those lines. The next type of architecture is a Kappa architecture, where it's simply everything is a speed lane, everything is real time, all that data happens instantaneously. The final one, and I made this one up, but I've seen this architecture a lot at lots of different companies, is just the batch architecture, where they don't account for that speed lane. We obviously landed on the flexibility choice, which is the Lambda architecture. Walking through this, we're going to peel back the layers here, step by step, but I want to emphasize another thing to recognize. There's really only 4 types of data pipelines that you're ever going to need to build. One of those is going to be the speed lane extract and load pipeline, where you're building a connector and then dumping it into your data lake. And the other one is the transformation. Typically on the speed lane, you're not trying to let that data go to rest. You need it to keep moving. The second type is the batch, the batch extract and load, and then you have the batch transform. Seeing those 4 types, we'll see how we've instantiated that at BENlabs. So in the top lane, you've got Spark. We've leveraged this tool because it's a tried and true technology. We can ingest and transform massive amounts of data from nearly any data source. We can dump that into our data lake in its original format, in the untouched bucket is what we call it. We're dumping CSVs, JSON, Avro files, you name it, Excel documents from various clients, right? It all goes here. The next part, we're moving that data in through our raw, intermediate, and final stages. Right here, I want to emphasize the importance of good, clean naming conventions and partitioning strategies. This is what affects and enables you to have clean data lakes and prevents it from becoming a data swamp. The next thing I want to illustrate is having the ability to get ACID compliance so that you're not losing data on read or write. This effectively allows you to treat your massive data lake as if it was a queryable database. We landed on Delta Lake because it has native integrations with Spark, but you could use Apache Hudi, you could use Apache Iceberg. There's other choices out there. The final stage that I want to talk about is kind of this lost art of dimensional modeling. Now, I love and promote Kimball dimensional modeling because I think it's easy and fast, but there's other types as well. The important thing here to take away is that you pick a paradigm that you're comfortable with and stick with it. Next, we'll talk about the cold store. We use Spark SQL, which is hosted by Databricks, to query that data. You can do EDA, let your data analysts go there, and do all sorts of things. Hot store for us is ClickHouse, massive amounts of data, querying that data, ingesting it, big aggregations in real time, and serving that up. Then we had to account for some special operation data stores, things like OpenSearch, Graph Database, MongoDB, or a vector database like Pinecone. Finally, you've got your access metrics layer and the different interfaces that allow you to basically serve any client. This is critical for all your engineering teams going downstream. And the things I want to highlight on the far left-hand side is that you can do GraphQL, REST API, and SQL endpoints, as well as streaming. So in summary, what I've shown you is with this type of architecture and some of the tools I've shared, we can virtually ingest any amount of data from any source at any scale and at any speed. I'm excited to introduce to you Eric Riddoch, who's going to talk about how we're building a ML platform at BENlabs.
Hey, that was a very graceful mount I just did on the stage. Yeah, super great to follow John Daniels because you can't have AI without data, so it didn't make sense to show, like if I had just shown you what I'm about to show you, then that probably would have been your first question. So he definitely set the context. Like John said, I'm Eric Riddoch. I lead the ML platform team at BENlabs. We've been building an ML platform for 4 years now, and we're doing some changes, moving over to Metaflow that I want to talk about in a sec. And I just want to say that as we've been navigating the very quickly changing MLOps tooling space as a mid-sized company, I can say it's been very stressful picking tools that meet our needs. And I really got a lot of value from talks that went into detail about how the choices were made to pick the tools they did and the actual workflow. So I'm hoping to get to that level of specifics in this talk today. So how did we get where we are today? We had ML Platform 1.0. We started building this in 2019. At the time, like John said, a lot of the tools were clunky to use, or like he talked about the limitation of SageMaker with a certain Python version. It felt like there were things like that across the board, and we thought that it was of the most value for us to roll our own platform, and so we did. And eventually, the complexity caught up with us, and our small but mighty ML platform team couldn't keep up with the feature requests the data scientists had. So we decided to simplify, and we simplified using Metaflow and another tool that I'll introduce in a sec called Bento Cloud. So what were we optimizing for when we were building our platform 2.0? This is philosophies. So we wanted reproducibility, automation, and flexibility. I don't think reproducibility needs any introduction, so I'll start with talking about automation. When we're talking about automation, the big cloud providers, Azure, AWS, Google Cloud, they've all come up with these rubrics about how to measure MLOps maturity. And basically, you're a 0 in your MLOps maturity for a project if nothing is automated, everything is manual. You're sending things, data files to each other, and in attachments and emails, like what do you mean? Where's the code? Like you have no DevOps and no automation. And then at the other end of the spectrum, everything is automated: training, retraining, deployment, serving, updating, all that stuff. But there are many ML projects you could pursue, and the sad reality is most fail. And so I don't know that we should invest the time in hardening all of them. For example, my friend Nick B and I spent a lot of time putting this service in production. I don't know that was a good use of time. We were trying to generate YouTube thumbnails for YouTubers, saving them that amount of time. And as you can tell, they look great. Like time well spent, obviously. So yeah, anyway. So was that worth optimizing? Probably not. Last principle, flexibility. Data science use cases are so variable. We need to be able to handle all kinds of data, all kinds of models or non-models, just algorithms, and then any sort of serving paradigm. And the hard part is we're not sure what those needs are in advance, and so we don't know what to optimize our platform for until those use cases come up. So we wanted to pick tools that supported this, scale what's worth scaling and make it straightforward to scale things when we want to, and also, be able to handle use cases that we've potentially never seen before from an architecture standpoint. So This audience probably is familiar with Metaflow, so I don't think I'll introduce that, but the serving layer that we chose was BentoML. This is an open source tool. It's really cool. You basically use a REST API framework in Python to define serving logic that you couple together, you bundle that together with a model. And what's cool is you can serve any sort of model trained on any sort of orchestrator, fetched out of any model registry, grab that together with serving logic, and then serve it in a number of different environments. Like if throughput's your problem, you could try the Triton inference server. If you need lots of memory, then you could do it as a UDF in Spark, or it could just be a REST or gRPC API. So this seemed like it really fit our use case, and we also thought the workflow was familiar. There were also a lot of other features. We didn't take the decision lightly, and I won't go through all these right now. So now, how do you use the platform? I'll see if I can get through this talking at double speed. So this is the data science lifecycle. I'll show you from the data scientist perspective how this platform is used. And just for context, at BENlabs, we kind of consider a data scientist an MLE, so we're sort of expecting this role to manage their own products from end to end, including in production and monitoring. So number one, it used to be really hard to get a data scientist up and running with a project, so we created this form that would generate a repo with some boilerplate code for them. But they still need access to the data and some compute, and that's where Outer Bounds comes in. They can go to this UI and actually provision themselves a remote workstation, which is great, because some of the advantages of remote workstations, you can connect to it with their awesome VS Code extension, that's really cool. Some of the advantages of remote workstations are they are very similar to your production environment, ideally. So on the same network as your data resources, similar cloud permissions, if not identical. You have access to GPUs, that was a sore spot for us, and the download speeds are awesome because the workstation's right there in their cloud. Unless it's not, we have an on-prem data center run by our very own Mike Priest, our data center admin, and the Outer Bounds team actually helped us install and configure Kubernetes on this system you see here. And so now from their UI with this toggle, we can actually choose if we want to leverage our own compute for our workstations, and I think that's really cool. Okay, so next step is training. I think in this room, we're fairly familiar with the fact that Metaflow has a lot of benefits, even at the earliest stages of experimentation. So you can use it to scale out your experiments run multiple instances in the cloud if you need to. You can use the resume command to only rerun steps. Don't rerun steps that you don't need to rerun, basically. And this is a DAG. This is a flow that we actually generate for the data scientists and let them fill in. And optionally, if they feel like it's worth it at this point, they can add tests. And they can use the BentoML's saving function to document exactly the environment that would be needed to reproduce the model in a serving environment. Once you've done some experiments, we're using Metaflow cards as our experiment tracker. It's awesome that they have this. If there's this question, are any of my experiments worth serving? We're using this Metaflow cards feature to answer that question. Once you have something that you think is worth serving, BentoML is a pretty simple tool to use. We have a file called service.py that we put into our repos. And you can see there's kind of like a REST API, SDK. So you basically define some endpoints to serve your model. And interestingly, even though you're defining REST endpoints, you still don't need to make any code changes to that to like serve it in all these other environments, which is so cool. But in the picture I'm showing, we're serving it as a REST API. So also, we generate a deploy flow. It works out of the box. If the data scientist runs it, it deploys a test endpoint to Bento Cloud, and then we'll automatically turn it off and do a prod endpoint. But if a data scientist wants to, they can insert integration tests, like load tests and quality tests, so you can make sure that nothing went wrong in the handoff from your training environment to production. As far as monitoring, with no effort, all the application performance metrics that a Bento service generates are shipped to our backend in New Relic, which is awesome. We even give them a dashboard that doesn't take any effort to create. And they can get alerts from PagerDuty and Slack on their phone if they want to. It's their choice. It's on them to keep their services up. And we also, with very little effort, a data scientist can actually persist all the inputs and outputs and intermediary steps when an inference is made to S3 without affecting the response time of a request. That's really cool because if you were able to put all your inferences into S3 in a structured form, you can run all sorts of monitoring batch jobs. You can integrate with other monitoring tools. It's awesome. You can also serve those inferences to downstream applications. So what about updating? So we talked about how on the MLOps maturity scale, we don't want to prematurely optimize and put things in production that aren't worth it. But let's say that you were a data scientist and you actually did fill out this training flow and you did fill out this deploy flow, which by the way, it's not that hard to do. The deploy flow only took the load test and quality test steps there, and the train flow is sort of like a natural part of their workflow. So if you have these two artifacts, you could automate your flow by, say, having your train flow trigger your deploy flow, which is awesome. And then if you wanted to further automate retraining so your models don't get scale, you could run them on a schedule, and that would be pretty easy. Or if you wanted to get fancier, you could run them on maybe an event that's emitted when some monitoring system has detected performance degradation. And if you've done that, you've achieved 100% automation for your project. And this workflow is amazing. I think it feels pretty natural for the data scientist. We're not really impeding them on progress when they're trying to experiment rapidly. But at the end of their project, it's suddenly very easy to put their thing into production. I think that's just really awesome. I think it's going to scale with us into the future for quite some time. So I think we concluded that this setup of tools, especially for a mid-sized company, makes reproducibility, automation, and flexibility very easy. So thanks for listening. John, you can wrap us up.
So to wrap us up, we just wanted to say this is how we've built, in order to build great data products, you've got to have data platforms and ML platforms. We hope you enjoyed our principles and some of the recipes that we've used to get there. Please remember to build with humans in mind. That is critical. And don't be afraid to lead. Get out there, try things, keep going. Finally, I'll say, join us in the creator economy. Thank you so much.
Thank you. Sorry, I jumped a little early there. We have time for a question or two if anyone has. Just make your way to the mic. And there's still some seats in front if you're standing in the back and would like to sit. If you want to stand, that's fine too. But
Hi. A bunch of us are snapping pictures. My basic housekeeping question. Can we get the slides?
I think it'll be shared afterwards. Yeah.
okay. Well, thank you so much.